What is opposite? Y divided by R, Y divided by R, that is AB divided by AC. If we want sin square theta is equal to 1 minus cos square theta, or if you want cos square theta is equal to 1 minus sin square theta. This is very important relation. What is adjacent from here? Adjacent is 4, hypotenuse is equal to 5. Adjacent side, this is adjacent is 4, hypotenuse is 5. Now what is PQ? PQ is equal to root of PR square minus QR square. Hello dear students, welcome to this session of basic mathematics class. I am Mr. Niranjan, faculty department of mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding very important concept, that is in angles and trigonometrical ratios. Now the very important concept is trigonometric ratios of an acute angle. This is very important concept. Now trigonometric ratios of an acute angle. So here in this session we are going to introduce the 6 trigonometric ratios of an acute angle and to find the relation between them. So here we shall introduce the 6 trigonometrical ratios, 6 trigonometrical ratios of an acute angle and also the relation between them. Now let us consider, let angle BOC is equal to theta radians, angle BOC is equal to theta, be any acute angle, and B be any point on the line OC, that is B be any point on OC, B is any point on the line OC, right. Then one of the boundary lines and BC, one of the boundary line of BC is perpendicular to OC, this BC is perpendicular to OC. Thus, we will have a right angle BOC, and the side which is opposite to this angle theta is an opposite side, and the side opposite to this 90 degrees is an hypotenuse side, and in between opposite and hypotenuse is an adjacent side. So here BOC is equal to angle theta, BC is equal to opposite side, and OB is equal to hypotenuse, and OC is equal to an adjacent side. So now here with respect to the angle theta, the side BC is called the opposite side, and OC is called the adjacent side, and OB is called as the hypotenuse side of the triangle with respect to the angle theta. So with respect to angle theta, this is angle theta here, then what is we have? This is O, then B and C. Therefore this is called an opposite side, and this is an hypotenuse side, and this is an adjacent side. So here the side BC is called an opposite, this is an opposite side, and OC is called an adjacent side, and OP is called an hypotenuse side. This is an acute angle, right. Now with respect to the angle theta, we define the following 6 trigonometrical ratios as sine of angle theta, then cosine of angle theta, tangent of angle theta, cotangent of angle theta, again secant of angle theta, and cosecant of angle theta. Let me explain in detail. Sin theta and cos theta of an angle can never be greater than 1, and the cosecant and secant theta of an angle can never be less than 1, right. So sin theta and cos theta of an angle can never be greater than 1. So it is not greater than 1, can never be greater than 1. Cosecant theta and secant theta of an angle can never be less than 1, and then tan theta and cot theta of an angle may have any numerical values, right. So in the right angle triangle as shown, let us consider, this is, let me call it as this is A, then B and C. So AB is an opposite side, and AC is equal to hypotenuse side, BC is equal to adjacent side. So let us represent the hypotenuse as R, R is the hypotenuse, opposite side is equal to, this is Y, and the adjacent side is equal to X, this is X. So X, Y and R. Now the 6 trigonometrical functions or the 6 trigonometrical ratios are defined as sine of angle theta is called sin theta. Sine of angle theta is called sin theta. Sin theta is equal to opposite by hypotenuse. What is opposite? y divided by r, y divided by r, that is AB divided by AC. And cosine of angle theta is defined as cos theta is equal to adjacent side divided by hypotenuse. Adjacent side divided by hypotenuse. What is adjacent? BC divided by AC. That is nothing but adjacent side is x divided by r. Sine of angle theta, sin theta opposite by hypotenuse, cos theta adjacent by hypotenuse, x by r. Now tangent of angle theta is called tan theta. Tan theta is equal to opposite side divided by adjacent side, opposite by adjacent. What is opposite? Y divided by adjacent side is x, y by x. Next, cotangent of angle theta is called cot theta. Cot theta is equal to adjacent side by opposite side. Cot theta is equal to adjacent by opposite. What is adjacent? Adjacent is x divided by opposite is y, x by y. Next, the secant of angle theta is called secant theta is equal to hypotenuse divided by adjacent side. It is hypotenuse divided by adjacent. What is hypotenuse? Hypotenuse is r divided by adjacent is x. And the last one, cosecant of angle theta is called cosec theta. Cosecant theta is equal to hypotenuse divided by opposite. What is hypotenuse? R divided by opposite is equal to y, r by y. See, these are the 6 trigonometrical ratios. Sin theta opposite by hypotenuse, cos theta adjacent by hypotenuse. So for sin theta and cos theta, the denominator is always an hypotenuse. So it will start from opposite. Sin theta opposite by hypotenuse, cos theta adjacent by hypotenuse. For tan theta and cot theta, there is no, it's a tangent, there is no hypotenuse. So opposite by adjacent is tan theta. If you reverse this, adjacent by opposite is cot theta. For secant theta and cosecant theta, hypotenuse is in the numerator. So secant theta is equal to hypotenuse by adjacent and cosecant theta is equal to hypotenuse by opposite. Okay. So if you know, just if you know sin theta and cos theta, sin theta is equal to opposite by hypotenuse. If you reciprocate this, so if you reciprocate 1 by sin theta, that is nothing but hypotenuse by opposite is nothing but cosecant theta. So the reciprocal of sin theta is equal to cosecant theta. Sin theta is opposite by hypotenuse, 1 by sin theta, cosecant theta, hypotenuse by opposite. Similarly, if you reciprocate cos theta adjacent by hypotenuse, the reciprocal of cos theta is secant theta. 1 by cos theta is secant theta. Secant theta can be written as hypotenuse by adjacent side. And similarly, tan theta and cot theta are related. So tan theta opposite by hypotenuse. If you reciprocate, if you reverse, you will get cot theta adjacent by opposite. So sin theta divided by cos theta will also give tan theta, or cos theta by sin theta will also give cot theta. That is the quotient relation. So these are few simple methods to remember the 6 trigonometrical ratios. Now move on to the reciprocal relation. Now these are all very important type of problems, are 1 or 2 marks. Now prove that sin theta into cosecant theta is equal to 1. Let us take LHS. LHS is sin theta into cosecant theta. What is sin theta? Sin theta is equal to opposite by hypotenuse and cosecant theta is equal to hypotenuse divided by opposite. Opposite hypotenuse gets cancelled is equal to 1 RHS. So sin theta into cosecant theta is equal to 1. So therefore we can write sin theta into cosecant theta is equal to 1. So if you want only sin theta can be written as 1 by cosecant theta. This is the first reciprocal relation. Or if you want cosecant theta in terms of sin theta is 1 by sin theta. So sin theta is equal to 1 by cosecant theta and cosecant theta is equal to 1 by sin theta. Similarly, we have second relation, that is tan theta into cot theta. Tan theta into cot theta is equal to 1. Let us take LHS. LHS is tan theta into cot theta. What is tan theta? Opposite by adjacent, and cot theta is equal to adjacent side divided by opposite. These two gets cancelled, that's equal to 1. So that means therefore tan theta into cot theta is always equal to 1. So if you want tan theta alone, so tan theta can also be written as 1 by cot theta. Or if you want cot theta is equal to 1 by tan theta. Sin theta into cos theta is 1, tan theta is equal to 1 by cot theta is equal to 1 by tan theta. So, if you reciprocate tan, you will get cot, or if you reciprocate cot theta, you will get a tan theta. So, the first one is sin theta into cosecant theta is 1, second one is tan theta into cot theta. Similarly, one more relation we have, that is nothing but cos theta into secant theta is also equal to 1. Cos theta into secant theta is equal to 1. So, if you want cos theta alone, cos theta in terms of secant theta is 1 by secant theta, or secant theta is also equal to 1 by cos theta, right. So, sin theta into cosecant theta is 1, cos theta into secant theta is 1, tan theta into cot theta is also equal to 1. What is to prove? Prove that sin square theta plus cos square theta is equal to 1. Let us take LHS sin square theta plus cos square theta. Now, let us consider an acute angle. Here, this is an angle theta A, B, C. This is 90 degrees. This is an hypotenuse, opposite and adjacent side. What is sin theta from this? Sin theta is equal to opposite by hypotenuse, that is nothing but AB divided by AC. And what is cos theta? Cos theta is equal to BC divided by AC. Now, substitute here. What is sin theta? Sin theta AB divided by AC whole the square plus cos theta BC divided by AC whole the square. So, this can be written as AB square divided by AC square plus BC square divided by AC square. You can take the LCM. What is the LCM? AC square is LCM. AC square gets cancelled. AB square plus BC square. Now, this is equal to AC square as it is in the denominator. So, if you apply Pythagoras theorem for this, AC square is equal to AB square plus BC square. AB square plus BC square. So, since AB square plus BC square is equal to AC square, this AC square and AC square gets cancelled, that is equal to 1, which is the required RHS. That is it. Okay. So, here take LHS sin square theta plus cos square theta. Sin theta is opposite by hypotenuse AB by AC whole square plus cos theta BC by AC whole square, that is AB square by AC square plus BC square by AC square. Take LCM, AC square is LCM, AB square plus BC square in the numerator. If you apply Pythagoras theorem, AC square is equal to AB square plus BC square. So, AB square plus BC square is AC square by AC square gets cancelled, that is equal to 1, which is the required RHS. So, this is very important formula indeed. Sin square theta plus cos square theta is equal to 1. Now, from this we have so many formulas. So, here sin square theta plus cos square theta is always equal to 1. If you want sin square theta is equal to 1 minus cos square theta, or if you want cos square theta is equal to 1 minus sin square theta. This is very important relation. Sin square plus cos square theta is 1. Sin square theta is equal to 1 minus cos square theta. Cos square theta is equal to 1 minus sin square theta. Now, move on to the second identity. What is the second identity? Prove that 1 plus tan square theta is equal to secant square theta. This is also same as that of the previous one. Take LHS. LHS is 1 plus tan square theta. This is equal to, let us write a right angle triangle. This is a triangle theta A, B, C 90. What is tan theta from figure? Tan theta, this is opposite, hypotenuse and adjacent. Tan theta is nothing but opposite by adjacent, that is nothing but opposite by adjacent, that is equal to AB divided by BC. What is secant theta from figure? Secant theta hypotenuse divided by adjacent, that is equal to AC divided by BC. Now, so substitute here. What is tan theta? Tan theta is equal to AB by BC whole the square. 1 plus this is AB square divided by BC square. Take LCM. BC square is LCM, cross multiplied. 1 into BC square is BC square plus AB square. Now, if you apply Pythagoras theorem for this, what is AC square? AC square is equal to AB square plus BC square. So, AB square plus BC square can be known as AC square divided by this BC square as it is. This is nothing but AC by BC whole square. Now, what is AC by BC? AC by BC is equal to secant theta. Secant theta whole square, that is nothing but secant square theta, which is a required RHS. That's equal to RHS. That's it. See here, very simple. Now take LHS. LHS 1 plus tan theta. 1 plus tan theta opposite by hypotenuse. Tan theta opposite by adjacent, that is AB by BC. AB by BC whole square. AB square by BC square. Take LCM. BC square is LCM. 1 into BC square is BC square plus AB square. So AB square plus BC square is also equal to AC square by Pythagoras theorem. So AC square by BC square can also be written as AC by BC whole square. What is AC by BC? Hypotenuse by adjacent is nothing but secant theta. Whole square is nothing but secant square theta. 1 plus tan square theta is equal to secant square theta. Now therefore we can conclude, therefore 1 plus tan square theta is also equal to secant square theta. Now from this we can derive so many formulas. See here, let us write a note. 1 plus tan square theta. 1 plus tan square theta is equal to secant square theta, or 1 can also be written as secant square minus tan square. If you transfer tan square to the right hand side, secant square minus tan square is 1. So if you want only tan square theta is also equal to secant square theta minus 1. So these are very important formulas again. So 1 plus tan square is secant square. 1 is also equal to secant square minus tan square, and tan square theta is also equal to secant square theta minus 1. Right. Now move on to the next one. So already first one is sin square plus cos square. Second one is 1 plus tan square is equal to secant square. And the third identity, what is left over? The third identity is cot and cosecant. How to relate 1 plus cot square theta is equal to cosecant square theta. Now let's move on to the next one. The third one, 1 plus cot square theta is equal to cosecant square theta. Take LHS. LHS is 1 plus cot square theta. Now let us draw a triangle, a right angle triangle. So here this is an acute angle, theta is an acute angle, A, B, C, this is 90 degree, opposite side, hypotenuse and adjacent side. Now what is cot theta from this? Cot theta is equal to cot theta adjacent by opposite, that is nothing but adjacent side divided by opposite. What is adjacent? BC divided by opposite is AB. And write down cosecant theta. What is cosecant theta? Hypotenuse by opposite. Hypotenuse is AC, opposite is AB. AC divided by AB. Okay, now let us substitute here. 1 plus, what is cot theta? BC by AB whole the square. So this can be written as 1 plus BC square divided by AB square. Take LCM. AB square is the LCM. Cross multiply. 1 into AB square is AB square plus BC square. Since if you apply Pythagoras theorem for this, AC square is equal to AB square plus BC square. So AB square plus BC square is equal to AC square divided by AB square. So this can be written as AC divided by AB whole the square. Now what is AC by AB? AC by AB is equal to cosecant theta. This is nothing but cosecant theta whole square. This can be written as cosecant square theta, which is the required RHS. That's it. Followed? 1 plus cot theta is BC by AB, BC square by AB square. Take LCM. AB square is LCM. Cross multiply. 1 into AB square is AB square plus BC square. Since AB square plus BC square is equal to AC square by Pythagoras theorem, AC by AB whole square. AC by AB is nothing but cosecant theta, that's equal to cosecant square theta. So what do you say? Therefore, 1 plus cot square theta is also equal to cosecant square theta. 1 plus cot square theta is equal to cosecant square. Now from this we are going to get 3 more relations, that is 1 plus cot square theta. 1 plus cot square theta is equal to cosecant square theta, or 1 is equal to cosecant square theta minus cot square theta, or only cot square theta is equal to cosecant square theta minus 1. So again these 3 relations, very important. 1 plus cot square is cosecant square, 1 is equal to cosecant square theta minus cot square, and cot square theta is equal to cosecant square theta minus 1. Hope you follow. So these three identities are very, very important, and the relations are so very important for solving the problems. Now move on to the next one. If sin theta is equal to 3 by 5 and theta is an acute, then find all the other trigonometrical functions of theta. Now what is given here? Given sin theta is equal to 3 by 5 and theta is an acute angle. So if theta is an acute angle, this is nothing but opposite by hypotenuse. So here let us represent this in a triangle. So theta is an acute less than 90 degree, opposite is 3, hypotenuse is equal to 5. So if you apply Pythagoras theorem for this, what is BC? BC is equal to root of AC square minus AB square. So what is AC square? AC square 5 square minus AB is equal to 3 square. 5 square is 25 minus 9, that's equal to 16. Square of 16 is 4. Since it is an acute angle, take positive value. Since you know 3, 4, 5 and are a Pythagorean triplet. So AB is equal to 3, BC is equal to 4 and AC is equal to 5. Now the remaining 6 trigonometrical functions can be defined as, find the all other trigonometric ratios. Sin theta is given. So what is sin theta? That is given sin theta 3 by 5. Next, cos theta. What is cos theta? Cos theta BC by AC. BC divided by AC. What is BC? That is 4 divided by 5. Next, tangent of angle theta. Tan theta. Tan theta is equal to opposite by adjacent. That is AB divided by BC. That is nothing but 3 by 4. And fourth one, cotangent of angle theta. Cot theta is equal to BC divided by AB. BC by AB. That's equal to 4 by 3. And the fifth one, secant of angle theta. Secant theta is equal to hypotenuse by adjacent, AC by BC. AC divided by BC. What is AC? 5 divided by 4. And the last one, cosecant of angle theta. Cosecant theta is equal to hypotenuse divided by adjacent, opposite, that is AC by AB. Hypotenuse by opposite, AC by AB is 5 by 3. See, sin theta 3 by 5, cosecant theta 5 by 3. Cos theta 4 by 5, secant theta 5 by 4. Tan theta 3 by 4, cot theta 4 by. So these are the remaining 6 trigonometrical ratios. Hope you followed. Very important. Now move on to the next problem. If tan theta is equal to 4 by 3 and theta is an acute angle, then find cosecant theta and secant theta. What is given? This is given. Tan theta is equal to 4 by 3. What is tan theta in terms of sides? Opposite divided by adjacent side. Now let us represent this in a triangle. This is an acute angle. Theta is an acute. A, B, C. Now what is tan theta? Opposite by adjacent. 4 and 3. So what is AC? AC is equal to root of AB square plus BC square. So that's equal to root of 4 square is 16 plus 9, that's equal to root 25, that's equal to 5. So as you know, 3, 4 and 5 are Pythagorean triplets. If AB is 3, BC is 4, then definitely AC is equal to 5. 3, 4 and 5 are the Pythagorean triplets. Now what is secant theta from this? Secant theta is equal to hypotenuse divided by adjacent side. That is nothing but AC divided by BC. What is AC? 5 divided by 3. Secant theta is equal to 5 by 3. And the cosecant theta. What is cosecant theta? Cosecant theta is equal to hypotenuse divided by opposite side. That is nothing but AC divided by AB. What is AC? AC is 5. AB is equal to 4. That's it. So if tan theta is equal to 4 by 3, then secant theta is equal to 5 by 3 and cosecant theta is 5 by 4. That's it. This is how we are going to solve this problem. Let's move on to the next problem. Secant A is equal to 2 by root 3. If A is an acute angle, then find sin A and tan A. What is given? Given that secant of A is equal to 2 by root 3. What is secant theta in terms of sides? Hypotenuse divided by adjacent side. Now let us consider this is the triangle. Let us call it as this is angle A, this is PQR. Now what is secant A? Secant A hypotenuse, this is hypotenuse and adjacent is root 3. If you apply Pythagoras theorem, PQ is equal to root of PR square minus QR square. So that is nothing but PR 2 square minus root 3 whole square. So root 2 square is 4, square root gets cancelled, that's equal to 3, 4 minus 3, 4 minus 3 is equal to 1, square root of 1 is 1. So this is equal to 1. So what is required to find is sin A and tan A. Sin of A, what is sin A? Sin A is equal to opposite by hypotenuse. What is opposite? PQ divided by PR. What is PQ? 1. What is PR? PR is equal to 2. Sin A is equal to 1 by 2. Opposite by hypotenuse. The second one, tan A. What is tan A? Tan A is equal to opposite by adjacent. Opposite is PQ. Adjacent is equal to QR. That is 1 divided by root 3. So, sin A opposite by hypotenuse 1 by 2 and tan A is equal to opposite by adjacent. What is opposite? 1, adjacent is root 3. That's it. Okay. Sin theta opposite by hypotenuse 1 by root 3. Tan theta opposite by adjacent, that's equal to 1 by root 3. 1 by 2 and 1 by root 3 are the required answer. That's it. Now move on to the next problem. Similar type problem. If cos A is equal to 4 by 5 and A is an acute angle, find the 5 trigonometrical ratios. Same as that of the previous problem. What is given? Given cos A is equal to 4 by 5. In terms of sides, cos A is nothing but adjacent side divided by hypotenuse side. Let us draw a triangle. This is angle A. Let us call it as P, Q and R. Now, what is adjacent from here? Adjacent is 4, hypotenuse is equal to 5. Adjacent side, this is adjacent, adjacent is 4, hypotenuse is 5. Now, what is PQ? PQ is equal to root of PR square minus QR square. That's equal to 5 square minus 4 square. That's equal to 25 minus 16 is equal to 9. Square root of 9 is 3. As you know, 3, 4, 5 are the Pythagorean triplets. Now, the sixth trigonometrical function, already cos is given. Write down the sine first. Sine of A is equal to opposite by hypotenuse, that is nothing but 3 by 5. Cos already given. Tangent of angle theta, tan A is equal to opposite by adjacent, that is 3 by 4, and cotangent cot A is equal to adjacent by opposite, that is 4 by 3, and then secant of angle theta is equal to hypotenuse by adjacent, that is 5 by, secant A is equal to 5 by 4, the reciprocal of cos, and the fifth one is cosecant of angle A. Cosecant of A is equal to hypotenuse divided by opposite. And what is the last? Cos A. Cos A from the figure is 4 by, that is cos A is equal to adjacent by hypotenuse 4 by 5. That is already given. So, sin A 3 by 5, cos A 4 by 5, tan A 3 by 4, cot is 4 by 3, secant A is equal to 5 by 4 and cosecant A is equal to 5 by 3. These are the remaining 6 trigonometrical functions. Now, move on to the next problem. This is also very important type for 2 marks. Now, what is given? If x is equal to a cos theta and y is equal to a sin theta, prove that x square plus y square is equal to a square. Very simple type and very important problem. LHS. What is LHS? X square plus y square. Substitute. What is x? X is equal to a cos theta whole square. What is y? Y is equal to a sin theta whole square. So, this can be written as, according to law of indices, a square cos square plus a square sin square theta. You can take common factor, a square out, cos square theta plus sin square theta. So, this is a square into cos square plus sin square is 1. 1 into a square is a square, that is equal to RHS, which is the required answer. So, therefore, x square plus y square is equal to a square. X square plus y square is equal to a square. Very simple. Just put x is equal to a cos theta whole square, y is equal to a sin theta whole square, a square cos square plus a square sin square, a square common factor. cos square plus sin square is 1 into a square is a square. Now move on to the next problem, similar type problem. If x is equal to a cos cube theta, y is equal to a sin cube theta, prove that x to the power of 2 by 3 plus y to the power of 2 by 3 is equal to a to the power of 2 by 3. Same type problem, LHS, x to the power of 2 by 3 plus y to the power of 2 by 3. What is x? Substitute. What is y? Substitute. That's it. X is equal to a cos cube theta whole raised to 2 by 3. Y is equal to a sin cube theta whole to the power of 2 by 3. Again law of indices. This is a to the power of 2 by 3 into cos cube theta whole raised to 2 by 3 plus a to the power of 2 by 3 into sin cube theta whole to the power of 2 by 3. This 3 gets cancelled. 3 gets cancelled. A to the power of 2 by 3 cos square theta plus a to the power of 2 by 3 sin square theta. You can take a to the power of 2 by 3 common factor. What is left over is cos square theta plus sin square theta. This is equal to a to the power of 2 by 3 into cos square theta plus sin square theta is 1. 1 into a to the power of 2 by 3 is a to the power of 2 by 3, which is the required RHS. That's it. Very simple problems here. Put x is equal to a cos cube theta whole to the power of 2 by 3, y is equal to a sin cube theta whole to the power of 2 by 3, a to the power of 2 by 3 into cos cube to the power of 2 by 3, a to the power of 2 by 3 into sin cube to the power of 2 by 3. Because you know in law of indices, a to the power of m is also equal to a raised to m into a raised to b raised to m, and similarly a to the power of m whole raised to n is equal to a to the power of mn. So a to the power of m. So 3 and 3 gets cancelled, cos square, 3 and 3 gets cancelled, sin square. In this you can take a to the power of 2 by 3 common factor. Cos square theta plus sin square theta is 1. 1 into a to the power of 2 by 3 is a to the power of 2 by 3. Same as that of the previous problem. Hope you followed all the trigonometrical identities as well as the trigonometrical functions. So this is very important concept. That's all regarding today's session. Let us meet with different types of problems in the next session. Thank you very much.